let's do question number 2. Question 2 says, a cyclist is traveling along a straight horizontal road at a speed of 4 meters per second. When she passes point O, she accelerates at a constant rate for a distance of 42 meters, reaching a speed of v meter per second. She maintains the speed v meter per second for 50 meters and then decelerates at 2 meters per second square before coming to rest. The distance traveled while decelerating is 16 meters. Find the value of v. Okay, and we have a part B to this question as well, that says find the total time for which she is in motion from the instant that she passes O. So trying to say this, that it is actually a question that we normally have a graph question, but they are not asking us to make a graph for it. Okay, sketch a graph. So but to understand it better, the best way is to make a graph for it, okay, and then try and solve it. So let's try and understand this whole scenario, the whole situation by a graph. We are making a velocity time graph. This is your velocity on y-axis and time on x-axis. Traveling along a straight road, horizontal road at a speed of 4. Okay, when she passes point O, she is moving with 4 meters per second. So that means the body is starting from 4 meters per second, not from the rest. Okay, so let's suppose this is your 4. Now, she accelerates at a constant rate for a distance of 42 meters. Okay, she accelerates and she reaches v. So let's suppose this is v velocity. And we know the distance is represented I'm really sorry, I'm having a very bad throat today. So we know the distance in a velocity time graph is area under the graph. So we can see that this distance that is covered here is actually 42 meters. Okay. Now, she maintains the speed of v meter per second for 50 meters. Okay, for some time obviously she maintains, when she covers 50 meters, so she maintains a speed v. So that means constant speed. So this area under the graph is 50 meters. Okay, and then decelerates at 2 meters per second square before coming to rest. So now there is a deceleration. Continuous deceleration until it comes to rest. So this is how it will be. What is the deceleration? For 2 meters per second square. Okay, so that means here the acceleration is 2 meters per second square. What is the acceleration in a velocity time graph? This is your gradient. Okay, v over t. And is 16 meters, and now the area under this graph will be 16 meters. Now we have to find the value of v. Okay, what information do we have out of all this? In this question, the information that we have in the first part is that it started from V to 4 to V. Okay, the second is we have in the second part of the journey we have V, but we don't know time. Okay, in the last part of the journey, there is a major information that we have, that is acceleration. So we can use that to find the velocity. Okay, and that becomes very easy, because as I told you that acceleration, yeah, we can use an equation of motion for this. We know v square is equals to u square plus 2s. So from here we know we know the final velocity? Yes, is 0. Initial velocity is v, that we need to find. Acceleration we know to be 2. Okay, why we are using this? Because this part of the journey, because this last part of the journey is the actual journey in which we have acceleration. In the rest of all we don't have, so we are not using those journeys to find out the v. So s is 16 meter. Okay, so we'll say here third part of journey or last part of journey, and applying this equation. So 0 square is equals to v square plus 2as. Okay, will acceleration be 2 or minus 2? As this is decelerating, so obviously minus 2. Okay, so here it becomes now v square minus 64 equals 0, and v square equals 64, and v equals 8. So from here we got this. We'll write this to be v equals to 8. Okay, this is what we found. Now let's move on to the next part. Find the total time for which she is in motion from the instant that she passes O. That means we need the whole time, this whole time in which these all three parts of journeys are covered. So for these three parts of the journey, we should be doing it individually. Now as we know the velocity, we know the both sides, and we know the area under the graph, so we can use that to find out the time. Okay, for the first shape, you can see what kind of a shape the first part of journey is making. It's making a trapezoid. So area of the trapezoid is height over 2 times the sum of the two parallel sides. Okay, so height, okay, what is height? Let's take this to be t1, this. So t1 times height over 2 times sum of two parallel sides. So which are two parallel sides? This and this. So what are these? 4 and 8. So 4 plus 8 equals, what is the area under this graph? Is the area of trapezoid is 42. Okay, so I made this expression, now I am taking it down. Part 1 of journey. So area of trapezoid is 42, so this is 42, so T1 from here will be 84 over 12, and that is 7. Okay, this is 7 seconds. Then we have the second part of the journey, that is, let's suppose we take it to be T2. Okay, we are taking them individually. So what is the area of the triangle, rectangle? So the second shape is a rectangle, so the area under the graph will be the area of the rectangle. Area of the rectangle is base times height. So what is base? Base is T2 times height is 8 equals 50. So this is your second expression. Second journey. Area of rectangle equals to 50. So T2 times 80 equals to 50, and T2 is equals to 50 over 80, and that is 6.25. T3. Third part of the journey represents a triangle. We know the area of triangle to be half base into height. Base is T3 times height is 8, and this should add up to, the sum should be equals to 16. That is the area under the graph. That is the distance covered. Area of triangle. So we have T3 to be 16 times 2 divided by 8. So we get it to be 4. So now the total time took by the cyclist to, from the time when she passes through point O till the end of the journey will be total time, and that will be equals to T1 plus T2 plus T3, and that is 7 plus 6.25 plus 4. They will add up to give you 17.25. Now let's show you the whole question. This is part A working. This is part B working. Okay, part 1 of the journey, we done it separately, second part of the journey, and third part and the last part of the journey. Okay, so this is your whole question.